Hi everybody, welcome to our video for our next computer lab assessment, which is looking at hypothesis testing, specifically for the F-test in Excel. So hopefully at this point you've watched the lecture material and gone through some of that. So what we're going to be doing is working on the F-test, again applying the exact same sort of procedure that we saw in lecture, but actually applying it in Excel. So it really is the exact same steps. So regardless of whether we do the process by hand or whether we use Excel to help us as a tool, we're still going to be following the exact same procedure, right? Step one, talk about the hypothesis statement. Step two, look at our significance level. Step three, degrees of freedom, critical value. Step four, I would strongly recommend a sketch sort of off to the side, but I'm not going to make you actually do that in Excel. So it's a little bit more complicated to draw a sketch in Excel, but the calculating the test value and then obviously creating our conclusion out of it. So we still will be following the exact same procedure, whether we're doing it in Excel or whether we're doing it by hand. So let's look at the example question in Excel. So as usual, I'm going to be working through the first example with you as an example, and then you have sheet 2 and sheet 3 will be your submission questions for the lab. So before we jump in, let's do sort of our admin type stuff as per usual. Please make sure that you're relabeling the tabs and putting a header on the first worksheet. So I'm going to do that quickly before I forget. So header, I'm looking for your name, your student number, and we're now working on our computer lab for the F-test. Similarly, sheet 1, please make sure that you are relabeling it as appropriate. And the context in this case is looking at the east versus west side, and this is actually a representation of the number of frost-free days. So I'm going to use that as my name for sheet 1, so frost-free days. Okay. And let's talk about the context of the question. So we have a raw data set for east side and we have a raw data set for west side. And they are, as I was saying, the number of frost-free days in the east and west side of Vancouver Island. So here's our question. So this is our research question. So is there a difference in the variation of frost-free days between the east and west side of Vancouver Island? So as soon as you're seeing that word variation, variability, variance, standard deviation, measures of dispersion, all of those mean that we are going to be running an F-test, right? So an F-test looks at the difference in variability or the relationship in variability. So as soon as we see variability, we're running an F-test. And then I see the word difference pop up there. So this is when we care about just difference. So we care about the greater and the less than side. So this would be a situation where we're going to run a two-tailed F-test. So what I'd like to actually do first is to run this procedure by hand. So I'm going to walk through what we would do by hand, what we've done in lecture. So I'm going to do that first. And then I'm going to show you how we do the exact same procedure using Excel's functionality. So I'm just going to, again, do the exact same question and show you where sort of all the numbers are coming from by hand. So if you want to sort of grab a piece of paper and do it along with me, or if you want to pause the video and try it yourself first by hand, and then we'll see how Excel will actually do that procedure. Okay, so here's the exact same question. I've just pulled it off into a Word document to sort of walk through it together. So again, same question. So is there a difference in the variation of frost-free days between the east and west side of Vancouver Island? So here's our raw data sets. So in order to actually run through a hypothesis testing procedure, I do need to have my descriptive statistics. And in particular, for an F-test, I need N and I need variance or variability. And it's always a good idea to do average as well, even though we don't actually need it for the F-test. So I'm going to do all of those in the calculator for the east side and then all of those for the west side. So let's start with the east. So I'm going to find my N value for the east. I'm going to find my X bar for the east, even though that's not really required. And I'm going to find S for the east. We can go a little bit further if you want to find S squared for the east. So I might as well do all of those for east, and then I'll do the same thing for the west side. And again, I'm just using little subscripts E and W to differentiate between the two. Okay, so let's start with the east side. So we have raw data, and it's obviously we're dealing with a sample in this particular situation. So let's start with our east side data. So I'm going to pull up my calculator, put it in stats mode, and find each of those calculations. So mode, 1 for stats, 0 for single dimension. Second function mode, make sure you have no data in there. And then let's input the east side data first. Okay, so 220 memory plus, 209 memory plus, 229 memory plus, 228 memory plus, 210 memory plus, 224 memory plus, and 226 memory plus. So alpha 0 gives me 7 data points. Alpha 4 gives me my X bar, so 220.857. And I'm going to keep at least 3 decimal places along the way. Alpha 5 gives you my sample standard deviation, 8.295. And then if I want to go a little bit further, I can square that value and get my variance value, which is 68.8095. So I'm going to get 68.810. Okay, and then I'm going to clear my data and put in the west side. So second function mode, clear all that out. And then let's put in the west side data. So 223 memory plus, 221 memory plus, 230 memory plus, 224, 223, and 230. So alpha 0 gives me 6 data points. Alpha 4, my mean is 225.167. Sorry, 225.167. Standard deviation, alpha 5 gives me 3.869. And squaring that value to get up to variance, 14.967. Okay, so we would like to see if there's a significant difference in the variation of frost-free days between the east and west side of Vancouver Island. So we're really comparing these two numbers. So do those two numbers look significantly different, 68.810 and 14.967? They do look significantly different in terms of just numerical values, but our gut doesn't always tell us if that's true or not. So we actually want to run through this procedure, run an F-test to see if these are actually significantly different or not. So again, it's sort of a question when you look at it, they do look quite different, but if you look at your actual numbers, they are quite high. So it's always sort of relative to the magnitude as well. So let's keep that in mind as we're sort of running through our F-test procedure. Okay, so step 1 is coming up with our hypothesis statements. So we're looking at a null and an alternative. So we're caring about variability. So we care about the variance in our population, right? So that's what we're extending to. So we want to look at the difference between the east side to see if that's different than the west side. So we're running a two-tailed test to see if there's a significant difference. Opposite to that is they are about the same. And we are going to test out that procedure and see, assuming that they are the same, let's see if we can disprove that. Step 2 is coming up with your level of significance. So alpha, there's no indication in the question, so remember our assumption is 0.05. And then we decide whether we're running a one-tailed test or a two-tailed test. So difference is a two-tail, so this is in two tails. So we are going to have to think about whether we do it by hand or whether we do it in Excel, adjusting our alpha as appropriate. So alpha is 0.025 in each tail. And Excel does run a one-tailed test as well, so we are going to have to put in that 0.025 into our procedure. Step 3, degrees of freedom and our critical value. So degrees of freedom numerator is NL minus 1, where N goes with the larger variance, and degrees of freedom denominator is NS minus 1, where N goes with the smaller variance. So looking at our variance values, the east side definitely has a larger value, so that's the one that we're going to put in the numerator. So we'll do 7 minus 1 gives me 6 degrees of freedom. And then denominator looks like, yeah, west side is the lower value, so I'm going to be putting in the 6 there. So 6 minus 1 gives me 5 degrees of freedom. Let's use that information. So 0.025, 6 over 5 in my table. So let's go to our F table, 0.025, 6 over 5. I'm getting 6.98 as my critical value there. Six over 5, yeah. Okay, so then let's draw our sketch. So remember the F is a right skewed distribution. It starts at 0. The mean is around 1. And 6.98 is up here somewhere. And that corresponds to 2.5% on this side. And again, because it's a two-tailed test, we do have another area over here, which is 0.025 as well. We just don't know what that value is from our table. Okay, so we know where our critical region is. We know what threshold number we have to get to. And then 5 is our test statistic, which is the larger variance over the smaller variance. So we said the east side had the larger one, so we're going to use the one that already has the square. If you're going to put in standard deviation, make sure you square that number, which will get you up to this one anyway. So I'm going to use my variance value. So 68.810, it's already squared in this number, divided by 14.967. So we can just plug that into our calculator. So 68.810 divided by 14.967. So I'm getting 4.597, etc., etc. I usually round that to 2 decimal places. And let's do our comparison. So it looks like it does not fall in the critical region. So we're down here somewhere. So in this situation, we're not in the critical region. That means do not reject our null hypothesis, which means we don't actually have a significant difference. So let's do step 6 and come up with our conclusion. So F 4.60 is less than my CV 6.98, or F is not in the critical region. Therefore, do not reject null hypothesis. So we were trying to get that proof by contradiction. So unfortunately we can't cross this one out and support this one. So do not reject. There's not any evidence of our alternative. So do not support alternative. So unfortunately, not necessarily unfortunately, we said that we were suspicious that there was a significant difference in the variability. These two numbers looked significantly different, but that's actually not true. They're not significantly different. And if we kind of look at the magnitude of the numbers, the original numbers, we can kind of see that the 68, maybe in the 14, don't actually, aren't significantly different. So let's write that as our conclusion. There is no significant difference in the variability or variation between the east and west side of Vancouver Island. Okay, so remember the not rule. Not in the critical region, do not reject, there is no significant difference. So again, we are suspicious that it was significantly different, but showing the actual procedure, we did not get a significant difference in the end. So let's see how we do that exact same procedure, but using Excel instead. Okay, so let's restart at the top. So we're going to restart with step 1. So we still want to sort of put down our hypothesis statements. Obviously, Excel is not going to do that work for us. So we are going to insert a text box and sort of do some of that step 1, step 2 procedure. And then Excel will do some of the other parts for us. So I'm going to first off insert a text box. And I'm going to do step 1 and step 2 in the text box first. So what I've done is up on D2L, I have put in a Word document so that you can copy and paste rather than having to type out all the subscripts, things like that. So if you download the Word document, I do have the 3 potential options for any test that you're doing. So it's about deciding which of these makes sense in the context of your question, right? So all 3 options are here, so that'll just save us a little bit of time. You can copy and paste. You just have to read your question carefully and determine which one of these is relevant. So I'm going to be using the first one. So because we're running a two-tailed test, I'm going to be using that first hypothesis statement there. So this is our two-tailed one. So I'm just going to copy and paste this into Excel. And I'm going to just do a little bit of manipulation because I like to sort of see them in this way. So we have our null hypothesis is that there's no difference, and our alternative is that there is a significant difference. These ones are general to 1 and 2. I'm going to ask that you please make sure that you change your subscripts related to the actual question. So I'm going to use a little E for the east side and a little W for the west. So I'm just going to change my subscripts there so that they're more relevant to my question. So at least I don't have to type the whole thing out, but I am going to be marking that you change your subscripts as appropriate. Okay, so we're going to assume that we have no significant difference and try to disprove it, right? So that's again our procedure. So step 1 done. Step 2 is our level significance. So this is our alpha value. So regardless of whether we do it in Excel or by hand, we're still going to make that judgment call. So there's nothing that it says in the question, so I'm going to run alpha at 0.05. And you can type in alpha, you can use A if you want to. I'm just going to go and insert a symbol and find my alpha. I like to use alpha. So it might be down here in your most recently used symbols. So mine is right there. Otherwise, you might just have to scroll a little bit and find your Greek letters. So here's our Greek letters right here. So alpha is right there. So I'm going to use it. You don't necessarily have to if you don't want to. You can just type alpha if you choose to. So alpha is 0.05. That's going to be our assumption unless it says otherwise in the question. And this is when you have to decide how many tails that you have. So we are dealing with a two-tailed test. So I'm going to actually write that in as well. So this is a two-tailed test because of that difference, right? So we care about the greater side and we care about the less than side. So this is a two-tailed test because of that difference. If you cared about greater, you cared about less. This would be a one-tailed test. This would be a one-tailed test. So you just have to watch your question again carefully to determine which one that you're using. So we're going to run 5% at 2 tails, which means that that 5% is in both tails. So in both tails, which means that we need to do our procedure where we cut that in half and run a one-tailed test with 0.025. So again, you still have to think about that procedure, whether you do it by hand or whether you do it in Excel. So we are going to cut our alpha in half, and this is in each tail. Excel will also always run a one-tailed test, so it's always going to look at one side. So it's important that you make sure that you're thinking about how many tails and distributing that over both sides. Okay, step 3 is our degrees of freedom and finding our critical value. So that is actually where Excel will save us a little bit of time. It will do that process for us. So let's see how Excel will actually run the F-test procedure for us, and then we'll have to do the analysis. So we're going back to the old data analysis. So data analysis, hopefully everyone still has that in their Excel document. So this is where we find the histogram function. This is where we did descriptive statistics before. And this is where we're going to find the F test. So I want you to find F-test to sample for variances. So that's the one that we're running. This is the procedure for it. So we'll hit OK. So notice your input, it has variable range 1, variable range 2. I usually just follow whatever order is given. The problem with that is that Excel actually might run a left-tailed test instead of a right-tail. So I'm going to show you both procedures. And I'll show you sort of after we run it through the first time. But if you put in the first one first, second one second, that should be fine. For most times I set it up that way so that it works out. But you can also switch them if you choose to. It's just going to change the side that you look at. So let's start with just putting variable range 1 in as the east side data. So I'm going to highlight all of east side. So A1 all the way down to A8. Notice I'm using the word east side as well. And then variable range 2, same thing. Highlight from B1 down to B7. And again, I'm choosing the words west side. So because I chose the words, I am going to check this labels box. So I did choose the labels, so I am going to check that box. If you only highlight the numbers, do not check that box because it will take your first actual value and it will create it as a label instead. So just be cognizant of whether you input the labels, check the box. It's just numbers you input, don't check that box. And then we have an alpha. So this is where we can change alpha. Notice it's defaulting to 5%. So we need to make a choice whether we want to make that change or not. So we are going to actually change this to 0.025 for this particular question because we're distributing that over two sides. So let's run it at 0.025. And then output's where we want to put it. It's defaulting to a new worksheet. I would like to keep it in this one. So I'm going to change my output range. And I'm going to put mine in D11. But you can obviously put it where you want to in your own document. And then we'll hit OK. All right, so this is our output for the F-test. So let's see what's actually happening here. So we have our mean. So that's our X bar values. So if we look at those numbers, we can compare them to what we got by hand. Where's my by hand one? Right here. So we got the 220.857 and 225.167 rounded to 3 decimal places. So again, they're giving the obviously the same values coming out there. Then we have our variance, so that's our S squared. So we got the 68 and the 14. So again, if we compare that, that would be our two S squared values that we got by hand. And then we have our observations. That's really N, right? That's our sample size. So in the east, we had 7. West, we had 6. 7 and 6. So that's our N values. And then we're getting degrees of freedom. So we're getting 6 for the east side, 5 for the west side. So those are degrees of freedom, N minus 1. And that was the same that we got down here, our 6 and our 5, when we did the subtract 1. So that's giving our degrees of freedom. And then if you notice these 3 below, so here's the critical 1 tail. So I'm just going to highlight that one. And I'm going to round that to 2 decimal places because this is actually from our table, right? This is, I'm going to write that in there. This is from the F table. So this would be like our critical value. So it says critical 1 tail, so 6.98. So notice that was the same one that we got, right? 6.98. Our table rounds to 2 decimal places. So let's round to 2 decimal places for Excel. So it gives you your degrees of freedom and it gives you your critical value. So step 4 is really creating our sketch. Again, I don't ask you to actually do that in Excel, but we can sort of have that sketch off to the side. And I would encourage you to do that to get comfortable with the hypothesis testing procedure. And then we have, here is our F value. So this is the actual step 5. So this is our F test value. And that was when we did that calculation of larger variance over smaller variance, right? So we did our larger variance divided by our smaller, and we got our test statistic right there, 4.60. So we're getting the exact same value. And then regardless, if we look at our picture, so it does not fall in the critical region. So yes, Excel will do some of the work for us, but we still have to interpret where these numbers are coming from and what's actually happening there. So let's actually insert a text box and make our conclusion. All right, so I'm going to do the same thing. So F of 4.60 is less than my CV of 6.98. So F is not in the critical region. So that means do not reject the null hypothesis or fail to reject the null hypothesis. Remember, those are the same thing. And you can go a little bit further if you choose to. So do not support the alternate or the alternative. So if I go back up to my original statements, I wanted to reject this one, but I couldn't. So there's no support that there is a significant difference. So again, same thing. Even though these two numbers look about the same, they're actually not significantly different than each other in terms of our test. So let's answer our original question. So our original question said, is there a significant difference in the variation of frost-free days between the east and west side of Vancouver Island? And I'm just going to say no to that question. So whether you want to copy and paste it down or whether you want to type it back out again, that's fine. So no, there is not a significant difference in the variation of frost-free days between the east and west side of Vancouver Island. So again, we got the exact same answer regardless of whether we did the procedure by hand or whether we used Excel, right? Excel does save us a little bit of time by doing all the descriptive statistics, finding the critical value, all that good stuff. So we should get the same result whether we do it by hand or whether we do it in Excel. As usual, Excel doesn't do any rounding. So it usually is a little bit more accurate, but we should be getting very close to the same values when we actually do the procedure by hand. Okay, so there's one value in there that we haven't talked about, and that's this p-value. So this p-value right here is another part of the lab that I do want to discuss with you. And it's a more modern type of doing sort of hypothesis testing procedures. And a lot of the time you're going to see a p-value, and p-values are a lot quoted in research, things like that. And I'm going to round it again to just 2 decimal places just so we can make it sort of relative. And notice the sort of notation. So it's the probability of getting an F less than or equal to F in the one tail. So this is actually a probability value. So this is actually an area that it's looking at. So this is really 6%. And what I'm going to note here is that this is actually comparing to alpha. So I'm going to actually go back to our diagram, and I'm going to show you what the p-value actually represents. So we want to compare to alpha. So it's an area that we're dealing with. So let's look at the actual diagram. Okay, so this was the diagram that we drew in the previous process where we did it by hand. I just blew it up a little bit. So notice that the 6.98, so this is our critical value. So the critical value is along the axis here, and it goes with an alpha of 0.025. When we do our calculations and we get a test statistic of F, that is along the axis, but there is actually an area associated with that one, and that is exactly what the p-value is. So in this case, our p-value is 0.06 or 6%. So you have a couple options. You can compare the axes, like we just did right here, or you can compare the areas. So that's another way that you can come up with the exact same conclusion. So notice if your p-value is big, like this one, it means that you're not in the critical region. So if P is bigger than alpha, then you actually get a do not reject. If you have a P that's less than alpha, so in a situation, say we got an F statistic up here, then your P value is going to be a lot smaller than alpha. So that would be a situation where we'd want to reject. So you have to be cognizant of which one you're using. Are you comparing area to area, or are you comparing axis to axis? So the P value, if it's larger than alpha, it's a do not reject. If it's smaller than alpha, it's a reject. So let's make that as well as a conclusion. I'm not going to actually get you guys to calculate p-values by hand, but we will see them in Excel, and you would see them in other statistical softwares if you did use them. So let's actually write a conclusion based on that as well. So compare to alpha, and if you want a little poem to remember, if p is small, reject the null. So if a p-value is smaller than alpha, you reject. If it's not smaller than alpha, if it's larger, then you do not reject. So you should never get a different conclusion between the axes versus the areas. So our p-value of 0.06, or if you want to type that out as 6%, if you prefer to see your areas as a percent, and this happens to be greater than my alpha value. And again, we're using the 0.25 because we're only looking in one tail. Or you can write that again as 2.5%. So this is a situation where we do not reject. And again, I'm not going to retype that out. It's just the same exact thing. But you can defend it both ways, right? So look at your axes, and then you look at your areas. So it's important to make sure that you're distinguishing between the two of them. But as we start working in Excel, we are going to start seeing those p-values more and more frequently. Okay, what I'd like to do before we actually close the example is that I do want to show you that Excel will actually do a left-tailed test as well. But you should never get this different conclusion regardless. So I'm going to redo, you don't have to do this part for for your actual submission questions, but I just want to show it to you just in case. So I'm going to again go back up to data analysis, and I'm going to rerun the F test, but instead of putting east side in first, I'm going to put it in second. So I'm just going to adjust my variable ranges. So I'm going to change variable range 1 to the west side data. And I'm going to change variable range 2 to the east side. So I'm just switching the two. And I'm going to obviously change where it outputs to. So I'll just put it off to the side over here. And I'll show you what that sort of looks like. So we got the same mean and standard deviation, variance, observations, degrees of freedom, obviously. You'll notice we get the exact same p-value. So it's still that 6%, so we can still compare that to alpha. But notice your critical now is less than 1. So our critical value, instead of being the 6.98, we're actually getting to 2 decimal places 0.14, and our F value, we're getting 0.22. So this is just giving you the left-tailed values instead. So in this one, we took our larger variance divided by our smaller. This one, we took our smaller divided by our larger. So it's just giving you a left-tailed value. So if you do actually go back to the picture we drew, we knew we had another side over here. And it just happens to be that this number right here is 0.14. So again, we don't have access to that on our tables because we only have a right-tailed table. But obviously Excel can do a left-tailed table as well. So this number is 0.14. And if I compared that to my F value of 0.22, I would still not be in the critical region, right? So regardless of whether I do it in the left tail or whether I do it in the right, I'm still getting not in the critical region. It would just change sort of this symbol. Looking at the left tail versus the right tail. So you get the exact same conclusion regardless. So just be cognizant that you could actually, depending on which way you put in your data, you will get different values there. But that's why P, a lot of the time people use that because it never changes regardless of which tail you're actually utilizing. So if you ever get stuck and you're like, okay, this is weird that they're less than 1, you can always just redo and put in the east side versus the west side. Okay, so you have 2 submission questions for me. Please make sure that you are going through the full procedure. You can copy and paste, but change your subscripts. Think about your alpha, run your test statistics, and then obviously you still have to do your interpretation.